Let's take a closer look at how sequence numbers and acknowledgement numbers work in the context of the buffers that must be inside a TCP connection. Since both the client and server for a connection can both send and receive, we're going to end up with 4 buffers. The sending side of a client has a buffer, and the data in that buffer is being gradually delivered to the receiving side of the server, and meanwhile the server's sending buffer, its data is gradually being sent to the client's receiving side. In our previous picture, we were thinking of these boxes as packets, but since TCP is stream-oriented and working at the level of individual bytes, and since acknowledgement and sequence numbers correspond to numbers of bytes, you should think of these boxes as individual bytes. Although we're drawing them here as being sent one at a time, they might be sent as chunks. So the fact that the client's sending side, that it is sent 2 bytes here, means that the packets that is delivering the third byte here is going to have a sequence number in it of 2, and the receive side here is going to acknowledge that by sending back a packet that has an acknowledgement number of 2. So that's how the packets that are meanwhile also sending data are going to have numbers from this connection to have acknowledgement numbers, and also numbers from this direction to have sequence numbers. In addition to acknowledgements and sequence numbers, packets have the window size that we just said existed but didn't talk about what it is. The window size corresponds to how much of this buffer, one end of a connection, is ready to have field. So when client is sending a packet to the server, it is going to report how much space is available in its received buffer that it can fill automatically. Because this picture is representing all the data that goes to the application, we don't necessarily need to keep the old data after it's been delivered to the application. We don't need to have room for all the data that will ever be delivered to the application, but a certain amount of space is going to be reserved. The other end can use that information to know how much data it should send at a time. It's no use sending twice as much data as the other end is willing to receive. And so built into the TCP protocol is a window size, because these windows can grow and shrink depending on what else the OS needs to do or how fast the application is receiving data. And so the server can adapt appropriately. So it's going to adjust these window sizes, where last time we talked about somehow you needed to pick a good size. It can pick a good size now because it's being told by the other end what is a good size, how much data should reasonably be expected to get there all at once. If on the receiving side the application is not receiving the data, it's busy doing something else and not paying attention to the network, then this window size could actually go down to 0, because there's no more room until the application starts receiving. So the other side needs to be willing to accept 0 as an answer, but then it shouldn't just get stuck forever sending 0 bytes. It should treat a 0 as basically 1. It should periodically try at least sending 1 byte, so it can discover that the window has gotten bigger and that it can send more, and so on.